Hello, let's check out this problem here where we have a limit where x is approaching infinity. In order to see what's going on, what we could do, and I think we shall do, is sketch the graph of e to the x, because we see that is here in our problem. We have e to the x right there. Okay, so for this e to the x graph, it's the exponential function. E is between 2 and 3. It's around 2.7. So if you're just saying, okay, I'd like to sketch the graph and plot points, you could sketch the graph of y equals 2 to the x. Sketch the graph of y equals 2 to the x, and then just say, well, that's about pretty close to y equals e to the x. So here's y equals e to the x, just roughly speaking. But sketch the graph of y equals 2 to the x, and you can get something that's pretty similar. And so if you want just plotted points, it's hard to plot points with e to the x because e's around 2.7. So what I'm getting at here with this drawing this, what's the idea here? Is to point out that the limit of e to the x as x goes to infinity is infinity. Why would I say that? Because if I hop on the curve here and x goes to infinity means x goes to the right, we see the graph grows without bounds. The y is getting bigger and bigger, nonstop bigger. That's what we mean by infinity. Now, back to this problem. This says e to the x. Here's another, well, this is e to the 2x. Okay, here I have a trick here. So I'm going to divide the numerator and the denominator by e to the x. The general principle being that I divide by the fastest growing term. I divide by the fastest growing term that's in the denominator. And actually, hold on. Should I divide by e to the x or e to the 2x? Maybe I'll divide by e to the 2x because it's the fastest growing term in the denominator. So yeah, actually, I'll divide by e to the 2x. So that little bit of indecision sort of ruined the video, but I'm going to keep going here. Okay. So it's true I drew the graph of e to the x. E to the 2x looks a lot like that. So we could even throw in this e to the 2x also has limit infinity. But e to the 2x goes to infinity a little faster than e to the x. I'm going to divide by that. Let's see what happens. I'm going to get x goes to infinity, 1 over e to the 2x minus e to the x divided by e to the 2x. Well, see, the thing is that okay, it's about to get into some explanation. Let's keep going. 1 over e to the 2x plus 2e to the 2x divided by e to the 2x. Man, math is not super easy, is it? Okay. Well, maybe it shouldn't be that bad. It's fun. Okay. Those guys cancel out. That was sort of the easy part. Now, the thing about this, let's just look at this as an aside. This is equal to e to the x, and then this part here, e to the 2x, this is the same thing as e to the x times e to the x. Or it's e to the x parentheses squared. But those, we get a little cancellation. So this is 1 over e to the x. I'm talking about this little piece right here. Let me put like a little bubble around there and look over here. Okay, so that this whole thing is limit x goes to infinity, 1 over e to the 2x minus 1 over e to the x divided by 1 over e to the 2x plus 2. All right, now the thing is I'm drawing the graph of e to the x. I think I just sort of copy and paste and get the graph of 1 over, or e to the, let me just do it. The graph of e to the 2x looks really pretty similar. It's just growing a little bit at a little bit faster rate. And so with that guy also, or gal, say it's a gal, e to the 2x, x goes to infinity also equals infinity. I mean, it's just growing twice as fast. If you want, sketch the graph of y equals 2 to the 2x. I mean, the thing is, if this is e to e, you could express this as e squared to the x. It's an exponential function. You could express this as e squared to the x. Okay. So the thing is that in this case, the denominator here goes to infinity, denominator goes to infinity, denominator goes to infinity. I'm not saying that 1 over infinity equals 0. I'm saying the limit of 1 over a function that goes to infinity is 0. The limit's 0. And then we're left with 2, so we get 0 over 2 equals 0. I think we should have maybe been able to see this right off the bat by saying, well, doesn't this grow faster than this here? The answer is yes. Another way to do this, which we haven't done in this section yet, is L'Hopital's rule. That comes in chapter 3. That would have actually saved ourselves some time, but this is a good way to do it too. Alrighty, so that's, I don't know if that was that good of a video, but I did it. And now if we move on to the next topic, the next thing, I was going to try to get a nice little rectangle around this. So thanks for watching. I'm not making any money off this. This is just a math video that could help. If it doesn't, I could try to do better. But, so, all right, thanks. Take care. Bye.